Continuing with the review for Mat 1100, Unit 2, beginning with number 27. In problem 27, they say that there are 16 marbles total in the jar, various colors, blue, green, and yellow, and they want to know what is the probability of selecting a blue or a green. Since selecting one color does not affect the probability of you selecting the other color, in other words, these are independent events, we are going to do this OR problem with using a plus sign. So we're going to do the probability of a blue. Any probability is a fraction. The bottom would be the total number of items, and the blue would be the desired outcomes out of the 16. So in this particular case, there's 5 blue, so 5 out of 16 chance of drawing a blue, or is synonymous to addition in probabilities, and then we're going to do the probability of selecting a green. Out of 16, there happen to be 8 green. So if you're giving this probability as a fraction, they have common denominators, so just repeat the common denominator, add up the numerators. That would be your answer as a fraction. Now in this particular problem, let me see if they've asked. No, they haven't asked you to round or to get a decimal, so we can leave the answer right there. Okay, problem number 28. In problem 28, you have a deck of cards, and they tell you there's 13 diamonds, 13 spades, 13 clubs, and 13 hearts. That gives you a total of 52 cards. 13 times 4, there's 13 of each suit. That's 52 cards total. Okay, and they want to know what is the probability of drawing a spade. And again, your probabilities are fractions. The denominator would be the total number of cards in the deck. And then we want to know what is the probability of drawing a spade out of the 52 cards. Since there's 13 of each suit, there's 13 spades. You could reduce that to 1/4. And in this particular problem, they have not asked for any kind of a decimal, so you can give the exact fractional probability, 1 divided by 4. Okay, problem 29. Problem 29, Jake works at a restaurant where the number of meals sold is greatly impacted by what day of the week it is. Identify the independent variable and the dependent variable. Okay, so there is number of meals sold, and then there is the day of the week. These are two things that are considered variables. It can vary. How many meals you sell can vary based on what day it is. And what day you decide to go in and check the number of meals that are sold can also be any day. So these are the two things that can vary in this particular situation. Now they say that the number of meals sold is dependent on the day of the week. So since the number of meals that you sell is dependent on this would be called the dependent variable. And the day of the week would therefore be the independent variable. Okay, problem number 20. Oh, that was 29, number 30. So in 29, you are given an equation. V is equal to 2 plus 6B is the value of the output. This is called the output, the variable that's by itself, also known as the independent variable, or the dependent variable, excuse me. This one's the independent variable, also known as the input, just to review some of the terminology with you. And that's actually the question, which is the independent variable? Okay, so this answer is dependent on what you put in here. For instance, if you put a 0 in here, you get 2 for an answer. If you put a 1 in here, you get 8 for an answer. So this answer depends on, therefore it is called the dependent variable, on what you put here. So if this is the dependent variable, this one's the independent variable, the one that can change and be whatever you want it to be. And then this answer waits to see what comes of the calculation. So this is the independent variable, which is what they were asking for. So B. Okay, 31. Zila works out regularly, has noticed there's a relationship between her muscle mass and the number of hours that she works out. And again, they want to know what is the dependent variable, what is the independent variable. How big your muscles are depend on how much you work out. So this is the dependent variable, and this would therefore be the independent variable. They're both variables, but this is dependent on this. 32. A construction crew is lengthening a road that was originally measured at 72 miles. The crew is adding 3 miles per day. What is the length of the road after 12 days? Use the equation. Length of the road is 72 miles plus yes, I believe there's a typo in this problem because the equation is given as 72 plus 2d, yet the wording of the problem is that they're adding 3 miles per day. So what is the length after 12 days? I'm going to go with the wording of the problem and just assume that the equation was written wrong. 3 miles per day. They want to know D stands for what day you're on, number of days you've been working. So we have a road that was originally 72 miles long, and they are adding to that road at 3 miles per day. Let's just go with the wording of the problem since there is an inconsistency here. Point is that you know how to plug into an equation. So if anything like that, this happens, you can just ask me. They want to say what happens 12 days into the project. Okay, so 3 miles times 12 would be 36. Add the 36 to the 72, and you get 108 miles. The road is now that length after 12 days. Okay, number 33. An exercise club is undergoing repairs and has lost the use of part of the facility due to the repairs being done. The club began with 192 members and is losing members at a rate of 3 per day. How many members does the club have after 22 days? That equation also seems to be missing something, so let me just repair it for you. Club starts with 192 members and is losing 3 members per day. So based on how many days you are going in and evaluating the situation, 3 have been lost per day. So they want to know how many members does the club have after 22 days. This D stands for days. So it started at 192, losing 3 members per day. We're now 22 days in. So it's 192 minus 66. So number of members after 22 days is 192 minus 66, 126 members. And that takes us all the way through